In triangles lesson, we have studied only two concepts. One is about congruency, the other is about isosceles triangle. Okay, only these two concepts that we are going to study. So first thing, it is congruence. What does it mean by congruency? Whenever we say two things are congruent, it means that both of the things are of same shape and same size. Congruent means what? Same shape and same size. Okay. When it comes to triangles, already we are comparing two same shapes only, is it? So it's already a triangle. So same shape need not to be checked. Same size only has to be checked. How we can check the same size? So the same size depends on two factors. One is corresponding sides are equal, and the other is corresponding angles are equal. Okay, the corresponding sides and the corresponding angles are equal. Okay, what does that mean by corresponding sides and corresponding angles? We say these two triangles ABC and this triangle PQR. When we can say these two are congruent means if the angle A should be equal to angle P, and then angle B should be equal to angle Q, and then angle C is equal to angle R. Then we can say, oh, not only that, this side AB should be equal to PQ, and the side BC should be equal to QR, and the side AC is equals PR. Then we can say these two triangles are congruent. Okay. How we have to mention that? How we denote that means this triangle ABC is congruent to triangle PQR. So this is what the correspondence means. Whenever we write like this, it does mean that this angle A is equals to angle P, angle B is equals to angle Q, angle C is equal to angle R. Also, the side AB is equals PQ and side BC is equals QR and the side AC is equals PR. Okay. Now, take these examples ABC and PQR. So here 4.5 centimeter, and then here 4 centimeter, here 5 centimeter, and then here 5 centimeter, 4 centimeter, and then here 4.5 centimeter, and this angle A, angle P, angle B, angle Q, and then angle R, angle C. Okay. So whenever I mention like this one side, this one angle, here one angle, that is equal. A is equals P, and the side B is equal. See, the angle B is equals Q, and then this angle C is equals R. So we can say this triangle ABC is congruent to PQR. You check this. A will be equal to P, one line, one line. B will be equal to Q, two lines, there two lines. C will be equal to R, three lines, there also three lines. And then the sides AB. AB is how much here? 4.5, and then here PQ how much? 4.5. Likewise BC. BC 5 centimeter, and then there QR is 5 centimeter. Got it? I think you got the idea what does that congruence means. Say yes or no, unmute yourself and answer. Okay. Now we have compared all the 6 elements of a triangle. Is it possible to compare the same thing again and again for all the time? No, it is not. So there comes, So there comes the congruency criteria. So instead of checking all the 6 elements, we can check only 3 elements, namely this congruency criteria or congruency rule. That is called as SSS congruency. And then, sorry, first one SAS, right? SAS congruency, and then ASA congruency, and then AAS congruency. After that, SSS congruency. After that, RHS congruency. Where S stands for side, A stands for angle. So, when it is SSS or SAS means, instead of all these things, the one included angle and the containing sides. Okay, for example, we have this angle, triangle ABC, here triangle PQR. In that, this angle C is equals angle P, and you say this side is equals this side and this side is equals this side. Okay, so in these two triangles we have angle C is equals angle P, and the side AC is equals PR, and the side what is that, BC is equals PQ. So we have one angle and the sides which are containing the angle, they are equal. So we can say it is SAS, side angle side congruency rule. Instead of checking all this, directly within these three results itself we can say they are congruent. How we can say, is that triangle ABC is congruent to triangle PQR? Will it work? The correspondence will come here? No. Why, sir? Then how it should be written? It should not be written in this way. How it should be written means, this triangle ABC is congruent to triangle, you see, side AC is there, right? AC is equals PQR, shall we say? Then P should be equal to C, then RQP. So when I say RQP means, you see, BC is equals PQ, yeah, okay. AC is equals PR, and then angle C is equals angle P. So RQP, got it? So this like correspondence should be there. That is what we are calling it as corresponding sides and corresponding angles. Okay. So instead of this side, suppose we have this side equal. Shall we use SAS congruency right now? Is it possible? Is it applicable? No, it's not applicable, because the containing sides are not equal. Okay. So this happens only these two are equal. Likewise, ASA congruence, as the name itself states that we have two angles and one side equal. So while comparing two triangles, ABC, PQR, or PQR and MNO, we have angle Q is equals angle N, angle P is equals angle O, and then side PQ is equals side NO. Okay. So we have two angle and one side equal. Then how we can say this triangle PQR is congruent to triangle, you see, PQ is equals what? NO. So we can write NOM, but before that we have to make sure whether P is equals N or not. No. So ONM, Onam, happy Onam. Okay. Got it? Are you getting it or not? So P should be equal to O, Q should be equal to L. Is it? Oh yes, it's there. And then PQ is equal. So instead of this, so this is what we call it as ASA congruency, meaning two angles under the common side, which is common for both angles, they are equal. The other one, AAS means instead of the common side, any other side will be equal. Take this triangle XYZ and DEF. Okay. So in this angle x is equals angle A, angle Z is equals angle D, and then this y is equals, see this yz is equals df. Then we can say two angle and one side is equal, whether that side is common for these two angles or not. It is not common. So we have to say it is AAS congruency. So AAS congruency means this triangle XYZ is congruent to triangle. Angle X is equals what? Angle E. Angle Z is equals what? Z is equals D. So EFD. But we have to make sure that whether YZ is equals FD or not. Yes, it is. Got it. Clear? Now answer me this question. Instead of this FD, suppose we have this side equal. In this case also we have two angle and one side equal. Shall we say these two triangles are congruent? No. Why? Because here it's a double lined angle arm. This is one lined angle arm. Okay. So that correspondence, that is what correspondence means. So it does not mean that only two sides one angle equal or two angle one side equals directly congruence. No, it is not. Even though they are equal, there should be correspondence. If there is no correspondence, it won't come at all. Okay. Any doubts on this? And then the other one, SSS congruency, name itself states that. Can you guess what is SSS congruency? All three sides should be equal. That should be corresponding sides. Okay. So I'll give you one example. You just say what congruence it is. This is what always RUN, and then this is DIG. These two are triangles, man, and this side is equals this one, this side is equals this side, this side is equals this side. So here what congruency does it follow? SSS congruency it follows. So we can say this triangle RUN is congruent to triangle BAG. Is it directly BAG? Then R is equals what? RU is equals what? BQ. BQ or BG, man. BGI. Don't say BGMI. BGI. Okay. Got it? Okay. So that is how we can say SSS congruence. And then RHS congruence, this is exclusively for right angled triangle. So the right angle, hypotenuse and one side. See, two right angle triangles, you can compare using this. See, one side, one angle, that is right angle, will be equal ABC and PQR as per tradition, and then the hypotenuse should be equal. Okay, so BC is equals PRQ, and any other side, this side or this side should be equal. Okay, then we can say RHS congruence. That means that this triangle ABC is congruent to triangle PQR. Shall we say? Like A is equals P, and then AC is equals PQ, it should come. PRQ, shall we write? AC is equals PQ. And then the other one, BC is equals RQ. Yes, it does work. So these two triangles are congruent by RHS congruence. So this is everything about congruence. Any confusions is there? You should not think that only S means side, A means angle. So we'll cluster everything. Three things you have to form: SAS, AAS, SSA. Likewise, all these things are congruency. Is that like that? Only these 5 fixed congruencies are there. Okay. And then the other one, The next exercise has the concept. What concept it is? About isosceles triangle. What's about isosceles triangle? Only two concepts. The thing is, shall I erase everything? You guys are not noting down anything, right? Good. Works for you. So the properties of isosceles triangle, in that when ABC is isosceles triangle such that AB is equals BC, that means isosceles, right? Two sides are equal. Then we have angle B is equals angle C. Reason, the angles opposite to equal sides of a triangle are equal. How do we prove that? We can draw a perpendicular. We can draw a perpendicular. I am drawing altitude. I am drawing. Okay, that is AD is an altitude. Then in these two triangles ABD and this triangle ACD, list out the common things. We have AD is equals AD, that is common, and the other one, what is that, man? AB is equals AC. You see here? Yes. Hey, don't you notice? Have you noticed or simply sitting? What you noticed, man? AB is equal to BC, sir. AC. Good. So AB is equal to AC, that is given, and then we have this angle D. Here angle D is equals angle D. Reason, each 90 degree. Now tell me what congruence, under what congruence this will come? Two sides and one angle equal. Must be SAs. Other than this, RHS. See, right angle, the hypotenuse and the one side. Okay. So they are RHS congruence. Got it? So these two triangles are congruent. So then we can say this angle B is equals angle C by what? CP, CP. What does that mean? Corresponding parts of congruent triangles. Okay. Got it? Now, if in isosceles triangles B is equal C, suppose in a triangle ABC, angle B is equals angle C, then we have to prove AB is equals AC. How we can prove? Not CP. This is different question, girl. This question, sides are equal given, angles are equal, we have to prove. This question, angles are equal given, sides are equal. Okay, that is what we are going to prove, girl. You should not use the same result directly here. How will you prove that? That's my question. See, let me draw angle bisector. When you draw angle bisector for this A, these two pieces are equal, right? And then we have angle B is equals angle C already. AD common. Then what congruency rule will give? ASA or AAS? AAS or ASA? Option A or B? AAS. Two angle on one side, that is non-common side. Okay. Got it? So that is the thing about this exercise. Now we will take this exercise 7.1. See the first question. Can anyone say how to prove that one? Yes sir, tell me sir.